Hi everyone, it's Miss Lopez. This is part 1 of your Cladograms activity. I've zoomed in on the images because you have the instructions in front of you in your notebook, and I want to make sure that you guys can clearly see what it is I am drawing. So let's go through this together. Part 1. A phylogenetic tree or evolutionary tree is a branching diagram or tree showing the inferred evolutionary relationships among various biological species based on similarities and differences in their physical or genetic characteristics. The pairs joined together in the tree are implied to have descended from a common ancestor. The closer the organisms are located on the tree, the closer their evolutionary history. And that's an important concept that I want to go through and highlight for you. So again, the closer the organisms are located on the branches, the closer their evolutionary history. Now let's take a look at an example of a phylogenetic tree. You'll notice that there are certain note points on here made for you. For example, here you see that the most recent common ancestor of A and B are marked here at this node. And then the most recent common ancestor of A, B, C, and D would be located here. So everything beyond this point or anything here would be the common ancestor for all of these organisms. This right here is referred to as the root. And typically when you see these, we are going to go from oldest species, oldest organisms, the ancestors, to present day species. So in this particular case, our timeline is moving from left to right, with the oldest being on this end and the younger organisms or the more recent organisms being on this end. So it says, your turn. Place a red dot at the common ancestor of C and D. So there's the red dot. The reality is we would accept an answer anywhere in this area right here, but it should in no means, shape, or form should it cross over or touch any line here where the arrow is pointing, or even here. This is too far back. So what we're looking for is anywhere from here, the tip of my arrow, down to this intersection here. But in keeping with what they've got going on up here, I went ahead and made my dot in a similar area. The next part asks, place a green dot at the common ancestor of A, B, and C. So there's the green dot. You can see that this common ancestor could also include D, even though it wasn't specified. A, B, and C, which by default also includes D, would have a common ancestor here. And in reality, you can put it anywhere along this line. What we would not accept is if your green dot in any way crossed over into this area here, because now you're going into E's territory, and that is no longer the common ancestor anymore. So even though technically putting a dot over here would be kind of a safe way to do it, you're not going to get credit for it because you're including too many data points. When they're asking for a common ancestor, you've got to try to make sure that your common ancestor includes only the ones provided. And if you can't, like, for example, on this one, we can't remove D. They're not going to take off points for that. But by trying to include E and putting your common ancestor here, that is not going to get you any credit. Speaking of E, notice that species E has no branching next to it. This is because it has no closely related species and nothing in common with the other species. Therefore, we considered species E to be the outgroup. Okay, now that you have an idea of the anatomy or the breakdown of the different parts of the trees, let's go through an example together. So what you're looking at here is a tree that is showing the relationship of various bears. And one of the things you're going to notice on this is that they've given you quite conveniently a number line up here at the top. And this is considered in millions of years ago. So this was 40 million years ago. And then as you move to the right, you're getting to more recent times, 0 millions of years ago. And here they have on here as your common ancestor is listed as the common ancestor of all modern raccoons, pandas, and bears. So not just bears, but raccoons and pandas as well. So this is their last common ancestor. In part 1, it asks you to refer to the model. So we're looking at the model. I've zoomed in nice and big. And it asks, how long ago did the common ancestor of all organisms in this phylogenetic tree exist? So the red dot I have placed is at the node of where the common ancestor exists. But the reality is, because of the way that this is drawn, you can also include this area right here, and your answer would still be acceptable. So what you're going to do is you're going to take that red dot wherever you put it on that line, and you're going to move your eye up to the timeline to see where that crosses. And so on these, you are going to have to estimate a little bit. And so on an answer like this, I would be looking for a range. This range would include anywhere between 27 to 31 million years ago. The next question asks, according to the model 1, when did the giant panda line diverge from the line that led to modern bears? So here is the giant panda, and where it diverges from the rest of the group, which are now known as the modern bears, looks to be about right here. And so when you look up on the number line and see where that number lies, it's roughly about 16 million years ago. So any value from 15.5, 16 million years ago is going to be accepted. The next question asks, according to Model 1, what animal shares the most recent common ancestor with the brown bear? So you can see that the brown bear is located all the way at the bottom of our phylogenetic tree. And to find out which one has the most recent common ancestor, remember what we talked about earlier, how the closer they are related, the closer they are on the tree. That means that the brown bear's common ancestor is going to be the polar bear. The next question asks, which of the two branches from the common ancestor in Model 1 has the most living descendants? So let's count those together. The top branch has 2 descendants. The bottom half, so think about it, if we just divide the 2 branches in half right here, this is the splitting. So you can see that the top half has only 2 descendants, and then the bottom half has way more. We've got 1, 2, 3, 4, 5, 6, 7 descendants. So the answer is the bottom half of the branches have the most number of living descendants. Question number 5 says, according to the phylogenetic tree in Model 1, the red panda is most closely related to which animal? So let's find the red panda on our tree. So there is the red panda. And what we're looking for is how close it is in terms of branches to other animals. So because the red panda is here, even though the common ancestor is all the way back here, the red panda and raccoon share a common ancestor at this point. So the red panda is going to be most closely related to the raccoon. Question number 6 asks, which are more closely related, the giant panda and the red panda, or the giant panda and the polar bear? Justify your answer using grammatically correct sentences. So the grammatically correct sentences and your justification is going to include the location, the physical location of the organisms on the tree. So are they close related? The other thing you're going to use in your justification is where their common ancestor is. First, I'm going to highlight the giant panda because this is the one I'm going to compare to the other bears. I'm going to start by comparing the giant panda to the red panda. And what I'm going to do is I'm going to start by looking at where that common ancestor is between the giant panda and the red panda. So their common ancestor, the node, goes all the way back to the last common ancestor. So I start at giant panda and I look for where is there a common branch for the red panda. And I have to go all the way back to about between 27 and 32 million years ago. Next, I'm going to compare the giant panda to the polar bear. And so I need to find the polar bear located on the graph. There it is in green. And now I need to see where the common ancestor between the giant panda and the polar bear is going to be. And it will be right here. So because the common ancestor for the polar bear and the giant panda is only about 16 million years ago, they are more closely related. Your giant panda and your polar bear are more closely related than the giant panda and the red panda. Even though the name makes it sound like they're similar, the giant panda and the red panda actually don't have a common ancestor, or they do have a common ancestor, but it is much, much older than the common ancestor between the giant panda and the polar bear, which is only roughly about 16 million years ago. For number 7, place a red star on the phylogenetic tree where the common ancestor for raccoon and red pandas would be. So there is the red star where the common ancestor for raccoon and red pandas are. For number 8, place a blue star on the phylogenetic tree where the common ancestor for black, polar, and brown bear would be. So there is the blue star where the common ancestor of black, polar, and brown bear would be. 9, place a green star on the phylogenetic tree where the common ancestor for giant panda and sloth bear would be. So there is the green star where the common ancestor for giant panda and sloth bear. I hope this video was helpful to you guys. This concludes the end of part 1.